Alright, so in this video I'm gonna be explaining another important article with the title SPGP Structure Prototype Guided Graph Pooling. This paper in NeurIPS 2022. While graph neural networks have been successful for node classification tasks and link prediction tasks in graph learning, graph level representations still remain a challenge. For the graph level representation, it is important to learn both representation of neighboring nodes, aggregation, and graph structural information. A number of graph pooling methods have been developed for this goal. However, most of the existing pooling methods utilize k-hop neighborhood without considering explicit structural information in a graph. In this paper, we propose structure prototype guided pooling that utilizes prior graph structures to overcome the limitation. SPGP formulates graph structures as learnable prototype vectors and computes the affinity between nodes and prototype vectors. This leads to a novel node scoring scheme that prioritizes informative nodes while encapsulating the useful structure of the graph. You see the concept of SPGP. SPGP first constructs the prototype vectors z of sub s, for example this one, z sub s1, z sub s2, z sub s1, z sub s2, z sub s3. And z sub s by utilizing bi-connected components. And clicks as the structure prototype. So their structure is limited to clicks and bi-connected components. The global structural importance of a node is calculated based on the information of the node itself and the affinities between the node and the prototype vectors, which are measured by relation modules q theta. Finally, with an auxiliary score, SPGP extracts important nodes to generate the pooled graph. So these are the main contributions. Proposing a new graph pooling that utilizes prior graph structures, which are hard to represent as k-hop neighborhood, to make more accurate graph representations with global structural information. We show that SPGP can capture structural information better than the existing pooling methods. Additionally, SPGP efficiently addresses the isolated node problem of graph pooling without computational expensive procedures. We have global pooling and hierarchical graph pooling. For example, diff pool, top K, sag pool, these are hierarchical pooling that I've explained in different videos. So the core idea of graph pooling is to select the nodes that are important in terms of graph as a whole. Unlike existing graph pooling methods, SPGP guides the learning process through the structure prototypes. It learns a node selector using structure prototype vectors, which constitute the graph structures based on node representations with contextual information. It learns the node importance by utilizing the structure prototypes and node representation, which contains the node contextual information. The global structural information contained in the SP is distributed to each node through the learnable structure prototype vector Z sub S. So R here is an aggregation function that integrates a representation of nodes belonging to S sub S. We utilize element-wise max operation to obtain the prototype vectors. So these are prototype vectors. Then using the structured prototype vectors, a prototype score can be calculated. Because it's Q theta of this plus W node H sub V. And W node is just a learnable parameter. But this Q theta here is relation module of the structure prototype SP of S. It's just a relation module that learns affinities between prototype vectors, these prototype vectors, and the node itself. So this is the structure similar between this one and this one. It learns the affinities between them. Specifically, it reminds me the idea of protonet that I've explained. Last year I explained it in a different playlist. It was few-shot learning that they use protonet as a representation. And this idea looks very similar because when we have HV here, it wants to set that it is into one of these clusters. So it measures the affinity between any of these combinations. Now we can concatenate the Z's and the HV tilde. And Z is in Z sub V, which I've explained. And W is learnable. Again, this one is learnable parameter. If the node V does not belong to the structure prototype, the relation module generates 0. So it's much more different than protonet, because even if it has also a null area that we assign it to 0 if it doesn't belong to any of these structure, because there are two structures in this paper, as I said, cliques and by components, by part components. Then we have auxiliary score that we utilize neighborhood information gain is an auxiliary score to obtain local structure information. So we aggregate representations of the neighborhood with the learnable projection function. Finally, the node score is expressed like this. Sigma denotes the activation function such as sigmoid. Based on the node scores, SPGP generates the pooled graph at layer k plus 1. So we have top k, and then we have a pooled graph. It can use any graph structure related to global information. So in this paper, as an example of the structure prototypes, we utilize two well-studied structures related to overall graph topology, the bi-connected component and the cliques. So a set of bi-connected components and a set of cliques are obtained by the graph traversal algorithm. So we assume that we have them, okay? Then for bi-connected component, we discard the bi-connect components with fewer than 3 nodes to avoid simple bi-connected components. For example, to avoid single edges. Now we define the structure prototype for bi-connected components like this. This is the structure prototype. Similarly, for clicks here, we also discard clicks with less than 3 nodes. So always we neglect the less than 3 nodes. A set of clicks can characterize the overall topology of the graph. So if adjacent clicks share more than half of the nodes, they are merged. Then we define the structure prototype for clicks. So this is a visualization of different pooling methods. The input graph is sampled from Frankenstein dataset. Orange nodes represent nodes belonging to a bi-connected component. Green nodes represent the nodes belonging to both a bi-connected component and a click. And we have these popular data sets for graph classification, that we have this score, which is much better than when we use just the GCN. If you compare GCN graph convolution with this, is a little bit better. For DD is much better.